All right, guys. So last week we looked at the formula force equals mass times acceleration. Uh, we are going to look at the relationship between mass and acceleration in this video. To look at that relationship, we can't just use the formula. So I'm going to draw the force triangle. So draw a triangle, F at the top, MA. So we know that there should be a divide symbol between both of these and a multiplication symbol here. Okay, so now to look at this relationship, we're going to have to figure out the formula to find each one of these. Okay, so we know the formula to find force. Okay, so force is mass times acceleration. So force is mass times acceleration. Now, if I want to find mass, then I cover up the mass and I look and see, okay, what is that telling me to do, the triangle? And that is telling me that I need to take force and divide it by acceleration, and that will give me the mass. Now, if I want to find acceleration, I cover up the A, and it tells me to take force and divide it by the mass. So in simple terms, if you have the force, then you're always dividing, and the force always needs to go into the calculator first. If you don't have the force, you're always multiplying. And you know you have the force or not by looking at the units. If you have newtons, you have a force. If you don't have a newtons, then you don't. So we have mass is kilograms and acceleration is meters per second squared. Now, what we've already looked at is that the mass and acceleration both have the same type of relationship with force. If you increase the mass, the force increases. If you increase the acceleration, the force increases. If you increase both, then the force really increases. Same thing if you're doing the opposite. If you're decreasing mass, you're decreasing force. If you decrease acceleration, you decrease force. If you decrease both, then it really goes down. But let's look at what happens to, let's say, mass if you increase or decrease acceleration. So to do that, we're going to need to use this formula. So I'm going to rewrite this formula over here just so that I have a little bit of room. Okay, so just like last time, we're going to hold the one thing constant. And in this situation, it's going to be the force. We're going to make the force 6 newtons. Okay, so the force is going to be 6 newtons. And we're not going to change that. Okay. Now what we're going to do is we're going to change the acceleration around and see what happens to the mass because of it. So we'll start off with our base and say, okay, for this one, we're going to say the acceleration is 2 meters per second squared. So if we put that in the formula, it's going to be 6 newtons divided by 2 meters per second squared. And that's going to be a mass of 3. The units for mass is kilograms. So our base, we're starting out with 3 kilograms for our mass. Now, what would happen if we increase the acceleration? Okay, so we increased A. Let's see what happens to mass. So we're going to make A, instead of being 2, we're going to make A 3. Okay, so we're going to say still 6 newtons. We're not going to change the force. Divided by 3 now, increased meters per second squared acceleration. So now 6 divided by 3 is 2 kilograms. So we increase the acceleration, and the mass decreased. So it did the opposite. Okay? So let's try that with decreasing the acceleration. So if we decrease the acceleration, we're going to say make the acceleration, instead of it being 2, we're going to make it 1. So 1 meters per second squared. So 6 divided by 1 is going to be 6 kilograms. Well, it basically happened again, right? We decreased the acceleration and the mass increased. So it still did the opposite. And I'm going to change pen color so it doesn't run together. So basically what we figured out is that if you decrease the acceleration, then you have an increase in the mass. If you increase the acceleration, then you have a decrease in the mass. That's called inversely proportional, but all you need to do is understand that happens. So basically, whatever you do to one, the opposite happens to the other one. So let's look at acceleration the same way. So this time we're going to be using this formula. So I'm going to rewrite it over here. Acceleration is force divided by mass. Now, just so that we don't get confused, I'm going to use a different force over here, just so that things don't look too similar. So on this side, I'm going to say my force is going to be 10 newtons. Okay? So I'm not going to change my force at all. And then I'm going to change my mass around this time and watch what it does to my acceleration. So we're going to start with a mass of 5 kilograms. And then we're just going to see what happens. Okay, so we're plugging everything into this formula. So to get my A, I need to put 10 newtons divided by 5 kilograms. So my acceleration is going to be 2 meters per second squared. So this is my base. This is what we're going to say we started with. Now, let's say that I want to increase my mass. Okay? So let's say I increase my mass. And I say, okay, this time I'm going to do 10 newtons of my force because I'm not changing my force. But instead of 5 kilograms, I'm going to increase my mass. Sorry, that's not going to look good. So I'm going to increase my mass. So if I increase my mass, I'm going to say, okay, now this time I have a mass of 7.5 kilograms. So I'm going to get my calculator on my phone, and I'm going to say, okay, 10 divided by 7.5 is 1.33, and I'm always going to round to 2 decimals. So that's going to be 1.33 meters per second squared acceleration. So I increased my mass, and that caused a decrease in my acceleration. So it did the opposite. So what if I decrease my mass then? Okay, so I'm going to go, this time I'm going to go my 10 Newton force. We're not changing that. So instead of 5, I'm going to say, okay, what if I have 2.5 kilograms? So I decrease my mass. So 10 divided by 2.5 kilograms. So now I have 4 meters per second squared acceleration. So I decreased my mass, but that caused an increase in my acceleration. So my acceleration was 2, but it went up to 4 because I decreased my mass. So just like on this side, when I was playing around with my acceleration, if I increase my mass, then the acceleration decreases. If I decrease my mass, then the acceleration increases. So that relationship basically works like whatever you do to the mass or the acceleration, the opposite will happen to the other one. So if you increase the mass, then the acceleration is going to go down. What that also means is that if you have a group of things that are, you're looking at the, like let's say you have a bunch of people running. Okay, let's put one more. So you have a bunch of people running. You can say they're all running with the same force. So they're all running with like 1.4 newtons of force. Okay, so if they're all running with 1.4 newtons of force, the same force, that means whoever has the biggest mass is running the slowest, because the biggest mass would have to be the slowest acceleration. Remember, if mass increases, then acceleration decreases. That also means whoever has the less mass, their acceleration is going to be the highest, because if you increase acceleration, that means the mass has to be small. So whatever you're looking at, these have to be the opposite of each other.